All right, good morning. Hi, my name is Solution, and my role for this project is called Architectures. And my primary responsibility was designing a resilient and a fault-tolerant infrastructure that could survive a real-time failures without downtime. If you look at this diagram, you see our core design philosophy, which is redundancy. We've deployed our resource across two separate availability zones, which is US East 1A and US East 1B. Traffic is managed by an internal-facing application load balancer, which acts as the single entry point for all users. Behind the scenes, an auto-scaling group managed our compute capacity. It serves two key functions, which is high availability and dynamic scaling. For high availability, it ensures we always have a minimum of two healthy servers is running. And for dynamic scaling, I have configured scaling policies based on the CPU utilization. If traffic surges and the load increase, the system automatically spins up new instance to maintain the performance. Conversely, when traffic drops, it scales back down to save cost. For today's demonstrations, we are focusing on the high availability aspect. Now, talking about resilience is one thing, but provide it is another. I'm going to demonstrate our system self-healing capacity live. Currently, you can see we have two healthy instances running that are handling our live traffic. In a traditional on-premises environment, if a server hardware fails, the website will go down until an engineer manually fix it. In our cloud architectures, we have automated this recovery. To simulate a catastrophic hardware failure, I'm going to intentionally destroy one of our active production server. I have just sent the termination signals. The server is now shutting down. In a normal system, this will be an emergency. However, our auto-scaling group is constantly monitoring the health of the fleet. Let's look at the activity history. It typically takes about 30 to 60 seconds for the health checks to fail. Wait for the log entry. Yeah, this is the log entry. I just did just now. You can see the entry terminating the E2C instance with the ID. The system detects the instances was terminated, but more importantly, look at the line immediate above it. It is launching a new E2C instances. The auto-scaling group realized that our desired capacity dropped below our requirements of 2. It didn't wait for a human to wake up. It immediately initiated the launch of the replacement server to restore our high availability. All right. If we go back to the interns list, you can see the old server is terminated, but a new server is already in pending or running state. This new server is running a user data script that automatically install Pythons, clones our latest code from GitHub, and start the web server. Within minutes, it will register itself with load balancer and start accepting the traffic. Moving on to the target group, we can see the new interns. Finally, checking on our target group, we can see the new instance has appeared and is initializing. Once it's passed its health check, the load balancer will begin sending it user. This demonstrates that our architecture is effectively self-healing and fault tolerance, satisfying the core requirements of high availability. Now I will pass to control to my partner, which is Fight, who will demonstrate the application's logic running on the infrastructure.
Hello, my name is Lau Bun Fai, and I'll be demonstrating my part in cloud computing project, role number 2, which is application developer and data lead. In this project, I have developed a simple inventory website that admin can add, edit, and delete shop items. Here, I will log inside to the admin account. This is the admin panel. Admin can read and update, delete, and create. So let's add a new record. As you can see, the carrots has been updated, added into the database, and we can also edit the record. And the record has been correctly updated. Additionally, I also added a user that can has different function. Here I'll demonstrate using a previously created user. Here, the user can see all the shop items. They can also add a shop item into their cart, such as this. So we can check their cart. Now we can see that tomatoes has been updated. Hold on. Here we can see the record has been correctly updated. They can also remove a record using this. And I will show you now the Amazon Dynamo database. Here is the previously created database. It hasn't been refreshed yet, so here's the previous records. When I refresh, we can see the new record has been added in, which is the carrots. The cards inside the user is also logged inside the Dynamo database, and also the users, including the admin. The cards is the inventory data is storing the image file. This one, as you can see, this one is the just now created one, the carrots file. All of this database is also backed up periodically to the vault, project vault, inside here. That's it. Thank you very much.